Hello there, ladies and gentlemen. Today we're going to look at focus topic number 5. That's right, for the purposes of this remote learning, we're going to skip focus topic 4. That's material that won't be on this year's AP test. But good information nonetheless. We're just not going to do it this time. Focus topic 5 is tables and Riemann sums. Uh, Today I have another shirt that's got some green in it, so you can see right through me. It's actually yellow, so must have enough green to make it disappear. That's kind of cool. So maybe I'll just start looking for shirts that have some green in it. That'll be cool. But enough about my shirt. Let's get on to focus topic number 5. Focus topic number 5 is on tables and Riemann sums, and I'll try to explain a few things, hit a couple main points, and then we'll do one problem together, similar to our last couple of lessons. All right. First of all, what students need to be able to do: find the average rate of change over an interval. Now, not to be confused with average value, but you would need to do both on a normal AP test. I think average value has been taken off of this one. I have to double check that. But average rate of change, very important. Approximate the derivative using the difference quotient. All right, this is when they give you 2 points in the table. If you have 4, 4 is 10 and 6 is 20, and they say what is the derivative at 5, you would just need to find the slope. Okay, so find the slope. Now, it mentions a few times in here, make sure you are showing your calculations for that slope. Leaving off the calculations could lose you some points, so you need to put the calculation. Use the two values closest to the number at which you're approximating. This amounts to finding the slope. Show the quotient, even if you could do that arithmetic in your head. All right, use Riemann sums, left, right, midpoint, and a trapezoidal approximation to approximate the value of definite integral. And typically with uneven subintervals, when you have anything but midpoint, they're usually even. But the others, they'll have uneven subintervals. Trapezoid rule per se, you're not expected to know any kind of formula. You're just expected to look at the trapezoid here, plus the trapezoid here, plus the trapezoid here. You're just adding up the areas. There's no formula necessary in that one. All right, find average value, average rate of change, Rolle's theorem, mean value theorem, all of these things could be in this type of question. All right, they reference to the 2007 AB number 3 question, and this score on this nationally was a 0.96 out of 9 points. So if you want to take a look at that one, you can see what they're talking about there. These questions are usually present in some context, and answers should consider that context, especially with your limits of integration. If it says from 0 to 5, integral from 0 to 5, you need to say what does that 0 to 5 mean. If you are asked to interpret the meaning of the integral, you need to include the limits of integration. And then unit analysis. A lot of times they'll say include the correct units. So very important stuff. Do remember this. Remember that you do not know what is happening between the points. Okay, so if you are given a table, we don't know what the heck is happening from, in between, like up above I wrote 4 to 6. We don't know that 5 is higher, lower, in between. We don't know. We just know that 4, we know 4, and we know 6. For example, don't assume that the largest number is on the table. Might be, but might not be. Show what you are doing, even if you can do it in your head. Okay, so show your steps, show your work when you're calculating, especially the quotients, when you're doing your finding your derivative or average rate of change. All right, do not do arithmetic. This is something that is hard for a math teacher to say, but you are not going to get marked down for leaving it unsimplified. If you have say a left-hand Riemann sum and you got all of your different areas added together, you can leave it just like that. You do not have to come up with one final answer and evaluate what that is. If you leave it all in the parts and say this, area 1, area 2, area 3, and like in calculating 1/2 base times height if you're looking at triangles, or base times height if you're looking at rectangles, so on. You add up those together, you can get an answer, but be warned, okay? If you have a correct answer and you simplify it incorrectly, you will lose that credit. So it was right, you simplified it wrong, you lost your points. So just a thought from someone who's been around these AP tests for a while. Do not find a regression equation. So I don't know that any of my students would do this, but if you've taken stats, you can look at the table and say, hey, I can just find a regression equation for this and use that equation to make all these other answers make some sense. Remember that regression is just an approximate. It's not exact, and that is certainly not the focus of your AP Calculus test. So, so this is not something that you may do with your calculator. The calculator is used for solving equations, finding derivatives, finding integrals, but nothing in there says you should be using your calculator for regression line. So let's jump in and we'll try one of these. We've done some of these in class, so hopefully this is going to make some sense for you. Let me go ahead and fold this paper. So we're going to get, this is 2011, number 2. This is a calculator question, so if you want to pause and grab your calculator, you're welcome to do so. Here we go. It says, number 2, as a pot of tea cools, the temperature of the tea is modeled by a differentiable function, h, for h is from 0 to 10, for t is from 0 to 10, where time t is measured in minutes and temperature h is measured in degrees Celsius. Values of h of t or selected values of t are shown above. So here's your time and here's your temperature. Question number 1. Use the data in the table to approximate the rate at which the temperature of the tea is changing at time 3.5. Show the computation lead to your answer. Even remind you, show the computations that lead to your answer. Okay? So very important. And you're going to want to write the numbers. Don't just write h of 0 and h of 2. And I'll show you what I mean by that in a second. So let's go ahead and try this first one. I'm going to just do it down here. This is letter A. And letter A, we're trying to find approximate the rate at 3.5. So we go up here. We know that 3.5 is going to be, now every AP test I've seen, it's always been exactly halfway between the two numbers shown. It doesn't have to be, but it always has been. So 3.5 is exactly halfway between 2 and 5. And so we're going to use these 2 points. We're going to use this point, 260, and this point, 5 and 52. Okay, so showing your computations, this is generally just a 1-point problem. So you just show your computations. And if you write down h of 5 minus h of 2 divided by 5 minus 2, this will not get you your full points. They want you to actually substitute those values in there. Okay, so if I were doing this AP test, I would not even do this step. I would just jump right into 52 minus 60 divided by 5 minus 2. And would this give you full credit? Absolutely. That answer would give you full credit. But you can simplify if you're interested. This is negative 8 divided by 3, negative 8 thirds. That is your average, how do I say? Approximate the rate at which the temperature is changing at t equals 3.5. That's your rate. So this is approximation, right? This is approximating h prime at 3.5. I should use approximately equal to. Okay, I'm kind of hidden. There you go. Some people wonder, Mr. O, do you have to include the units? This did not say anything about including units, so you would not get marked down for not putting units. Next one says using correct units, so obviously then you would have to do that. So would I use units? Yeah, I probably would, but again, you're not going to lose points if you don't, not if it doesn't say so. What would the units be? Well, on the top we have degrees Celsius, on the bottom we have minutes, so degrees Celsius per minute. So negative 8 thirds degrees Celsius per minute, excuse me. All right, B. Using correct units, explain the meaning of this integral in the context of the problem. Use a trapezoidal sum with 4 subintervals indicated by the table to estimate this. Okay. So first of all, what does this mean? Using correct units. So I'm integrating. The integral is of h. H is in degrees Celsius. So I integrate degrees Celsius, and I'm integrating with respect to time. So this is what gets kind of confusing. If there was going to be a unit for that, it'd be like adding a unit of time. So it'd be like a degrees Celsius minute, which does not make any sense to us. But luckily we have this divide by 10 or multiply by 1/10. what is this? Well, this part here, if you remember our formula, we have an integral, and we're dividing by an interval. Sounds like a song that I heard once. Integral, interval. Oh, I know. That's right. Integrate, divide by the interval. You got it. So what are they asking you to do in this particular integral? This is looking for the average value. This is the average value. And average value of what? Average value of temperature. So this integral, B, saying evaluate, sorry, we're on B, using correct units. So the units would be integrate, you would get degrees second, degrees Celsius, minute, and then you divide by how many minutes have gone by, you'd get a unit of degrees Celsius. So it says using correct units, explain the meaning. So let's say this integral is the average temperature of the T from 0 to 10 minutes. Okay, so you want to include all the different parts of this, right? You want to include, first of all, what is the integral telling us? The average temperature and of the T from 0 to 10 minutes. Very important, like I was saying earlier. You want to include the limits of integration. If you did not put the 0 to 10 anywhere in your answer, you would certainly not get full credit. The integral is the average temperature of the T from 0 to 10 minutes in degrees Celsius. Okay, because they asked us to use units. And then it says, explaining the meaning, and it says use the trapezoidal sum of 4 subintervals indicated by the table, all right? So trapezoidal sum, we're going to use trapezoids to calculate 1, 2, 3, 4. So I would say area 1 equals, I like to do this because I think it helps me to stay organized. So my first trapezoid is going to be from 0 to 2. And that is the distance between my bases. So base 1 is 66, base 2 is 60. And the distance between my bases of this trapezoid is 2. Okay, so it's 1/2 66 plus 60. Those are base 1, base 2. And then multiplied by the height, which is the distance between them, is 2. The second one, now I'm going from 2 to 5. So the distance between them is 3. One of the bases is 60 and the other one is 52. Okay, so this is your base, and your height is how far apart they are. So we go back to here, we say 60 plus 52 times 3 this time, because that's how far apart they are. And then area 3 and area 4. Area 3, I have 1/2 base 1 and base 2, and if you remember from the table, 52 and 44. And how far apart are they? They are 4 apart this time, because how far apart they are is from 5 to 9. That is a 4, distance of 4. And then we have our last one, 1/2 base 1 and base 2, 44 plus 43. 44 and 43, and then their distance apart is only 1. I'll put parentheses on that if I like. Okay, now certainly this will not be the final answer. But what I was saying earlier is you do not have to calculate all of this out. Like if you wanted to write this as, how do they ask it? Let's see, use the estimate. So I would say 1/10 times the integral from 0 to 10 of h of t dt is approximately, and I could write all this out. I could say, well, all of these are multiplied by half. If you didn't want to simplify this at all, you could write each of these and then just add it with plus signs between. But since they are multiplied by all by a half, I could simplify a little bit. Well, forget it. I'll just write it all out. 1/2, and you can say 66 plus 60 times 2 plus 1/2, 60 plus 52 times 3 plus 1/2, and what else we got here? 52 plus 44 times 4 plus 1/2, and the last one hopefully fits. 44 plus 43 times 1. I'm not going to write the 1 because I don't have space. But that is an answer. That is correct. Okay. If you wanted to know what all that was, I'll add it out. 52.95. Oh, geez. Almost got it dangerously wrong. This is the integral. You would have to multiply the whole thing by 1/10 or divide by 10. So very important. Geez. 1/10. Let me circle that in blue. Yeah, I got the integral here, but don't forget your 1/10. And when you did all of that out, you should get 52.95. And this is a calculator problem. So you could have just punched all that in your calculator and got your answer. 52.95. Okay, let's look at the question again so you make sure we get all the parts. Using correct units, degrees Celsius, explain the meaning. The integral is the average temperature of the T from 0 to 10 minutes. And the context of the problem is 0 to 10 minutes and the T, the temperature. And then it says, use the trapezoid sum, which we did. 4 subintervals indicated by the table to estimate. This is your estimate. Okay, so we got all the different parts to that one. All right, let's look at C. So letter C. Evaluate the integral from 0 to 10 of h prime of t dt using correct units. Explain the meaning of the expression in the context of the problem. Okay, so first of all, we evaluate. And if we're going to look at C, the integral from 0 to 10, h prime of t dt. Well, integrating the fundamental theorem of calculus says the integral would be h of 10 minus h of 0. This is a derivative. If I integrate, I get the actual function, and I'm going to plug in a 10, I'm plugging in a 0. So this is just testing your knowledge of the fundamental theorem of calculus. H of 10 we get from the table, 43. H of 0, 66. So my answer for this, 43 minus 66 is a negative 23 degrees Celsius. So there you go. Using correct units, got my negative 23 degrees Celsius. And now we have to explain the meaning of the expression. This expression means that the temperature of the T has dropped 23 degrees Celsius in the first 10 minutes. All right, now on a highlight, you have to mention the interval. When you're explaining, you have to mention the interval. So don't just say the T has gone down 23 degrees. It's not enough. They want to know that you understand the integral part, the limits of integration. Okay, so the temperature has gone down. How is this? When you have a rate of change and you integrate, you get the actual amount. So this is how much the temperature has changed. It's gone down 23 degrees in the first 10 minutes. Okay, you want to use degrees Celsius for the units. Now let's look at D. All right, times T equals 0, biscuits now, with a temperature of 100 degrees Celsius were removed from the oven. The temperature of the biscuits at time T is modeled by a differentiable function B, for which was known that this is your B. Using the given model, at time T equals 10, how much cooler are the biscuits than the T? Right, so we know that the T is 43 degrees Celsius. So we just need to figure out the temperature of the biscuits. We're good to go. So if we want to find out, this is a rate. So if we want to know what the temperature of the biscuits at 10 minutes, we're going to have to integrate because they give us a rate. And it is known that the biscuits are 100 degrees Celsius when you get out of the oven. Then we take our integral from 0 to 10 of your b prime. And if we can integrate this, this is our temperature change. The T went down 23 degrees Celsius. This will give us our temperature change for the biscuits, and then we can compare them. Okay, so this we would use our calculator to integrate, and I have already put the expression in the calculator. As you can see here, you can't see there. There you go. Negative 13.84 e to the negative 1.73x. That's what I have here. Double checking. And so that's in my y1. I did not need to put in the y1. You could have done all this in your home screen if you like. But I go math 9. I'm going to integrate from 0 to 10. And I'm integrating, I use the alpha F4. I'm going to integrate y1. So that just saved me a little bit of time. Hit X there. This is how much the temperature has changed. You need to remember that it started off at a certain temperature. This is just how much it's changed. So the biscuits have not dropped to negative 65 degrees Celsius. That would be a very cold biscuit. So I do 100 plus my answer there. I got and I get 34.1827. So I'll just go ahead and put this on my paper. Equals 34.1827528. Okay, that's the temperature of the biscuits. That's the biscuits at 10 minutes. All right. We know that the temperature of the tea at 10 minutes from the table is 43 degrees. This is degrees Celsius, this is degrees Celsius. We know both of those. All right, so the question says, double checking, how much cooler are the biscuits than the tea? So we do H of 10 minus B of 10, and that we subtract 43 minus our answer that we just got, and we get 8.817 degrees Celsius. So, ladies and gentlemen, this is a typical style problem, very typical for it to start with question like that first type of question. Then using correct units and talking about the integral. I'm guessing there will not be anything with the 1/10 out there, but you will have to interpret integrals for sure, and accumulation and how things have changed. And then they jump into some other, usually introduce another equation where you can do some comparing. But using the calculator to integrate is very important as well. Well, let me know if you have questions. I'm happy to help in any way. Comments on here, send me emails, whatever it might be. And I hope you all have a wonderful day.